So hello, Professor. I hope that you're doing good. Now I'll try to present the proof for the second max, having a number of comparisons equal to n plus log n minus 2. So let's take, for example, this following tree. So with 8 elements. So each element has a weight of 1. And let's complete the tree. So each element compares to the element next to it, and finally gives a max, which is this one. So as you can see, we have 7 comparisons as we studied. So each element with the one next to it. So these with each other. So 1, 2, 3, 4, 5, 6. And 7. So to find the maximum, as we studied, it's n minus 1. So let's go back to the tree. So for example, this is the max. So this is the max, and here it is again, the max. It just traces back. This is the max. And so now let's go to the elements that lost to the max. For example, this one, and this one. So let's try to create a tree from these 3 elements. So let's use another color. So we will have no, yeah, so we will have 3 elements. These will compare with each other, and this one with another one. So we have 1 comparison and 2 comparisons, which is, so let's give these. So for these elements that are that faced the max and loss, let's call them m. And we have m minus 1 comparisons to find their max. So to find the second max, we need n minus 1 plus m minus 1. So let's try to clear the board. So we said n minus 1 plus m minus 1, which is m plus n minus 2. And as I said in the first minutes, so it was n. The proof, it says that we need n log n plus n minus 2 comparisons to find the second max. So now we need only to prove that this m is bigger or equal to log n. So let's try to clear the board again and leave this part. So let's try to create another tree, but this time it's a weighted tree. So we have 8 elements, each one with 1. We start with 1. And we have a winner and a loser. So the loser gets 0, and the winner doubles its weight. So for example, here it becomes 2, this one gets 0, this one gets 0, this one gets 2, this one gets 0, this one gets 2, and this one gets 0, and this one gets 2. And next to these will face each other, so this one gets 4, this one becomes a 0, this one gets 4, and this one gets a 0, and finally we have this one with the 8 and the 0 here. So as you can see, it doubled, double, and double again. So for the times that it doubled, it's log of n. So for example, we have 8 elements, and the times it doubled is 3, and 3 equals the log of 8, log base 2 of 8. So as I said previously, so m presented the number of the elements that faced the max and loss, which was 3 in this case, and log n equals 3, as I mentioned. So this shows that this is true. So let's try to clear this board again. So this shows that the proof is n plus log n minus 2. And so let's try a last example to check that this is true. So let's try a bigger tree this time with the 12 elements. So we have 4, 6, 8, 12. So this is good. So now each will compare to the one next to it. 5 elements. Is with this. This will compare with this, and this will compare with this to give this one. So to find the second max, as we said, it's n plus log base 2 n minus 2. So n here is the number of the elements. So as we said, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 minus 2 plus log of 10. And log of 10 is equal to, let me let's search online. 10. So this is log 10 equals to 3.321 and so on. So that for the log of 10, so it becomes 4. Since we get the number that is next to, that is higher than 3. So it becomes 10 minus 2 plus 4. So it is equals to 12 comparisons. So to make sure, so 1, 2, 3, 4, 5 is 6, 7, 8, and 9. So now we got the max. So we go back. So all the elements that face the max. So we have 1, 2, 3, and 4. And now we compare these 4. So 1 again plus 2 to give the last. So 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7, 8, 9, 10, 11, and 12. So that's it. We found the same number, so it's 12. I hope that this was a little bit clear and I made some sense. And that's it. Thank you.